more of these. So this system of inequalities just has two inequalities. The top one is y is less than 1/4 x plus 2. Now, the one I did right before this, the inequalities were in standard form, and so the easiest way to graph those was by finding the x and the y-intercepts. These are in y-intercept form, so these are in y equals mx plus b form. And when they're in this form, you use the slope and you use your y-intercept and just graph them using those two pieces of information. So y is less than 1/4 x plus 2. I'm going to graph that just like that, where y equals 1/4 x plus 2, which means my y-intercept is 2. My b value is 2, so that's my y-intercept. And then I'm going to use my slope, which is the number in front of x, which is 1/4, and the fact that I know that the slope is the change in y over the change in x, or the rise over run. So I'm going to go up 1 and then over 4. And there's going to be my second point. Now, I only need 2 points for a line. Okay, my line is going to be dotted because that line is not included in this solution because it's less than, not less than or equal to. And then I'm going to use my test point 0, 0. And when I plug in 0, 0, I plug in 0 for y and 0 for x. I get 0 is less than 0 plus 2. Well, that's true because 0 is less than 2. So I'm going to shade everything towards 0, 0. So that's that first inequality. All right, now I'm going to look at that second inequality. And I've got y is greater than or equal to 2x minus 5. Same thing, it's in slope-intercept form. I'm going to start at my y-intercept, which in this case is -5. 1, 2, 3, 4, 5. So I've got that point there going through the y-intercept. And then my slope is 2, or 2 over 1, because it's a whole number. So I'm going to use rise over run again. I'm going to go up 2 and over 1. So that's going to give me my other point. Now this line is going to be solid because it's or equal to, so that line is included. So I've got this solid line going up there. Then I'm going to pick my point 0, 0 again because it's not on the line, so it's going to always be my go-to test point. When I plug in 0 for x and 0 for y in that second inequality, I get 0 is greater than or equal to -5. Well, that's true statement too. So I'm shading everything toward my test point, or 0, 0. Okay, so I'm going to color everything, my solution set, and this one, I'm going to color it in black again. So it looks like to me that my solution is doing this thing right here. So it's everything in there, and then it continues on and on. All right, now notice that all sides of my solution are not enclosed. So this side right here is, this side is, but this over here, that's just open. So this is not bounded. Remember, to be bounded, it has to be enclosed on all sides. So this is not bounded. And then the only other thing I need to do is find this vertex. There's just one vertex, so it's right there. And actually, I guess technically that would be an open circle because this inequality was a dotted line. That doesn't matter. You just find the vertex, the point where they meet. So I'm looking to see where this blue line and this red line intersect. And if you have problems just looking at that and trying to see what that is, you might glance at it and go, well, I know what that is. But if it's in between whole numbers, then you're going to have to set up your system of equations and actually find where they intersect. So in this case, I've got y equals 1/4 x plus 2 and y equals 2x minus 5. So the easiest thing here is going to be to use substitution. So I'm going to take y equals and plug it in to this top equation. So wherever there's a y, I'm plugging in 2x minus 5. So 2x minus 5 is going to equal 1/4 x plus 2. And I always get rid of fractions if I have them by multiplying by the common denominator. So I've got 4 terms here. I'm multiplying all 4 terms by the common denominator. That's just going to give me 8x minus 20 equals x plus 8. And then I'm going to solve that for x. So I'm going to get 7x equals 28, or x equals 4. And once I've got x equals 4, it's very easy for me to plug that into another one of my original equations, which I'm going to use the one without the fraction in it. So I'm going to get y equals 2 times x, which was 4, minus 5, or 8 minus 5, so y is 3. And like I said, you might could have just looked at your graph and been able to tell that this vertex was 4, 3. But in case you can't, you have to set up a system and solve it, just like we did in the earlier sections.